So he asked if for the multi-column list box you wanted some extra functionality for just a specific multi-column list box, where would you do that? Would you do it in the main VI event structure, or would you do it in the BRAC VI? Yes. So, can you hear me? Or?
Yeah, I think you can, yeah.
Okay.
No, do you want to show it? Do you want to
No, it's okay. That's a tough one, that, because you've got then this contention between, if you do it in the main VI, you've got this contention then between the BRAT that's handling certain things, and then you have got your control coupling nightmare of who's controlling this multi-column list box. So yeah, either expand the BRAT.
It's like I'm filtering my columns, or something. Would that be an example?
Yeah. If you wanted to deal with specific things, then you're almost getting into the realms of dealing with classes, and I want this particular instance of a BRAT to run for this VI, a different BRAT to run for a different VI, and then you get in.
And all of a sudden, our simple solution carry out.
Yeah.
That's probably where I've had things a bit like that before. I've gone away from a BRAT and just made like an API approach instead.
But it's great for resizing from panel to the largest decoration.
Right. So for the CLA summit, I'm presenting on something called debugging and immediacy. To take my 45 minutes down to about 30 seconds, is people, I think, may have forgotten what LabVIEW is for and why it's good. And the thing, because I've done lots of textual-based languages, lots and lots and lots, and the thing for me that made LabVIEW good was what I'm now calling, because I couldn't find much on that, is immediacy. Is that I can very quickly do something, it doesn't work. That immediacy, it's this, it's the potter's wheel, it's the feedback, it's from the IDE. It gets quite deep on a psychological level quite quickly. But essentially, that's the heart of where I'm going with this. This is the thing, and I think an awful lot of the architectural work that's going on in the CLA world is stopping that immediacy, because now I can't run a program and see what it's doing. It's calling several things down through several layers, doing lots of abstract things. So I thought, well, there's an issue. I'm going to start looking at it, and I dug around. I've done lots and lots of research. And I come up with this guy. He's kind of interesting. He does this example. This is JavaScript.
Think about coding. Here's how coding works. You type a bunch of code into a text editor, kind of imagining in your head what each line of code is going to do. And then you compile and run, and something comes out. So in this case, it's just JavaScript drawing to a canvas, and it draws this little scene with a tree. But if there's anything wrong with the scene, or if I want to make changes, if I have further ideas, I have to go back to the code. And I edit the code, compile and run, see what it looks like. Anything wrong, I go back to the code. Most of my time is spent working in the code, working in a text editor blindly, without an immediate connection to this thing, which is what I'm actually trying to make. So I feel this goes against this principle I have, that creators need an immediate connection to what they're making. So I tried to come up with a coding environment that I thought might be more in line with this principle I have. So what I have here is I've got this picture on this side and the code on this side. And this part draws the sky, and this draws the mountains, and this draws the tree. And when I make any change to the code, the picture changes immediately. So the code and the picture are always in sync. There's no compile and run. I just change things in the code, and I see things change in the picture.
Stop him there.
And now that we have this immediate connection between the code and the picture, we can start thinking about ways of changing the code.
Well, I thought. So this was late 2012. and this just is cited all over the place. And all the JavaScript, oh, they're all getting very excited about this. And I thought, I can do that. I've been able to do that for 20 years. What's the big thing? This is a big thing. They see so much in this. That example in 2012, so everyone got a terribly exciting thing with this JavaScript tool. It's completely contrived, and you know it's completely contrived because, having now tried to write it myself, is that it comes onto a number, and as the presentation goes on, he goes, oh, you may want to change this, and he right-clicks, and it's a slider. And he goes, slidey, slidey, slidey. And all that crowd go, woo, get very excited, because he's sliding. Well, the thing is, that's a double. Now, if you right-click on that and bring up a slider, well, it's going to be huge. It's going to be vast, isn't it? Because it's a double. So it's obviously that slider knows it's for trees. So it's completely and utterly contrived. But everyone went off and started trying to write these immediate languages. But the thing is, I got so excited because of that, because of the immediacy of it. And so, so I started looking, I think, I don't really know 2D picture rings. I know what I'm going to do. I'm going to try and do the tree in the 2D picture rings. So, of course, this is, I'm just hopeless with maths and stuff. But I'll show you how far I've got. It's pretty colours, because it's pretty colours. So what I've done, there's a reason they're all pretty colours, because I'm trying to work out what the recursion is doing. But what I've gone through is the code. I thought, right, I'm going to do that in Levy. So there's gaps, obviously, and I think where it's contrived, I think there's gaps as well. So my idea being that rather than have those constants in there, is that all you actually have to run is your block diagram, and you bring up your draw mountains. Mountains there. There's your variables. So the big thing he's sort of showing is this will be a bit clunky now because I'm a tree building, but essentially you can change the sky colour. We've got it. This is JavaScript want this. We've had this. This isn't new. This is there. But I mean, there's a lot more to my presentation than that. I wasn't only 5 minutes. But what I would quite like to do is to just replicate that. The bit I'm struggling with now is so I've got the mountains and the sky drawn. They're easy. It's just a gradient, which is pretty easy. The tree is a little bit more tricky. So the tree, and this is hideous. So what he's got is a recursive draw branches. So I've chopped each little bit of code. So this is currently long and hideous and big. So I've started. Essentially, you've got a bit of randomizing for branch lengths, for angles, various things like that, and then he calls them again. So when he goes to the top of the trunk, he draws 2 branches. When he goes to the top of the next branch, he draws 2 branches. After so many iterations, he doesn't draw 2 branches anymore. He draws 1 branch, and they go off in slightly different angles. And then branch number 6, he starts putting blossom on. Essentially, that's how it works. So you can see I've put colours in here so that I can actually tell which iteration, because recursion does some funny things. So me, being a simple soul, I thought recursion is going to go 0, trunk, branch, 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 in order so I can see it growing. Well, that'd be fun. Nah, don't do that. It doesn't all ask about face. It's doing a predictable way at all. So that was my first issue. So I was trying to work out which one goes where. The next thing is just simple maths. I'm trying to work out from an angled rectangle where the center point is so I can put it on the tip. Because in the draw rectangle. So if you've done 2D picture control stuff, it's probably quite easy. But I'm a div when it comes to this sort of stuff because I've never really used it. So if I pause it, I'll show you what it's doing. Because once I've cracked it, I've only been playing around with it a couple of evenings. It's quite a bit untidy. So let me run it again, if I can find it. Boink. Yeah, so that's colour blocks. The first rectangle to come up with my recursion thing is that one there, which is oh, stupid.
Have you given it a trunk?
Yeah, I have. The trunk is there, but it's going to draw it last. I don't know why. I'm going from 0 upwards, but it's going to draw the trunk last because it's recursion, and I'll get confused with it. But yellow. He's in there somewhere. Who's
Isn't that because you've got your draw rectangle at the end of the recursive call there?
I think it probably is. I need to break out the draw rectangle as well because the rotate needs to come out. The draw rectangle was a problem for me. Yes, so I think he needs to go there, and his outputs need to come into here because that's the bit I'm trying to get my head around now. I mean, it's a case in point because I'm using LandView to do the immediate stuff because I'm maths stupid. I need to work out what a rectangle is and how to find all this basic geometry that I never do anymore.
Yeah, it's co-ors.
Yeah, just so my end point is really yeah. Don't catch me out later on. Yeah, so my end point is
other than typing. So for example, this number here is the length of the branches. If I want to control that number, I just point my mouse to it, hold down the control key, and I can dial it up and down. So I can see what it looks like for big branches and small branches, and I can kind of converge on what feels right to me artistically. And this works for any number of the code. I just point to it, dial it up and down. And some of these numbers here, I know what they do, but it's still kind of surprising to see them do it. And other ones are just completely surprising.
Yeah, so the thing I'm aiming for really from the presentation point of view is just to say, look, that was a huge thing. And even now people are trying to recreate that in text-based languages. But with us, all we have to do is on a sub-PI, rather than use a constant, use a variable, stick it in the local bit, pop it up, jobs are good. And actually it's there. But then we go and ruin that advantage. I mean, the more psychological point of what I'm sort of saying is that I program by debugging. And it's a terrible thing, you know, bad me. But that's what I do. I drop take a 2D array, I drop it down, chuck a number in, look at the output, I've got that spare face once again. So, and that's how I program. I don't remember 2D. I really don't want to use my brain for remembering syntax. And that's completely different.
Test-driven stuff gets you as well. Like, I've had it at the minute, been refactoring a database library, and if I was trying to refactor that in the main application, it would be an absolute nightmare. So I have to fix it all and then see what's working. But using unit testing, I've basically got a setup VI that sets up the database in a known state, runs my VI, literally a twiddle a number, run it, that's still not quite right. Change the call slightly, run it, it's still not quite right.
Well, see, I'm moving into areas where you treat the block diagram as a user interface, which is a bit of a mind swipe, but you apply design rules to the block diagram that you would apply to the user interface. Things like spatial, immediacy, spatial performances, things like this. You sort of saying, well, I mean, the dumbass thing we do is we drop, say I've got in the event structure, I've got a button. I drop the button in the event structure, so I go on the block diagram, on the front panel, I right click on it, go find, oh, there it is, and I've got that immediately. I'm talking to my program and I'm interacting. And I'm worried somewhat sometimes that we're busting that, you know. We're doing programming from the project screen. And I mean, if you look at the debugging tools that are available, they're the same debugging tools that have been available for 15 years now. The block diagram is not being, thought about. There's other ways that people program. I mean, I like to right-click on a queue, for example, right-click on a queue and see a list of all the things that are going on in the queue. Should be able to pop that up. I want to see that now. You should be able to. One of the demos he does here with a games program is you run a little games program, you press pause, but it doesn't just stop it. You can take a little slider and go back in time. And there's no reason why a VI shouldn't have buffered time. So why should I not be able to pull back in time and go and visualize it? The highlights tool has been the same for donkey's years. Why can I not stop that and go?
Are you saying if you pause it, you should be able to change the block diagram and then start again?
I think you can do stuff like that. Yeah. But no, what I would like to see is a sub-VI. And I'd like to, even if I'm saying I'm in debugging mode now, please log everything, every node for the next 2 minutes. Whatever, taking two examples. Pause it, and then be able to run through its history with a little slider bar. Seeing all the outputs change, then go back. Seeing all the outputs change.
But there is some weird thing built into that that logs every call or something.
It's not far off. You can do it. I'm sure it's doable, but nobody probably ever asked because my thinking has changed by looking at the block diagram as a user. It changed the way you think about things. You think, because I've always, I just use the tool I'm good at. So if somebody gives me a curvy knife, I'm going to use a curvy knife, and so I'm not going to think about a straight knife because I'm giving a curvy knife. But it's only when you look for my brain, I start looking at these things in a slightly different way. Wow, we got these advantages, and it's always been the disadvantages of LabVIEW people are crying about, sort of low user interface and stuff like that. It doesn't matter to me. It's debugging. I need to be able to debug quick. That's the heart of my programming style. It's the heart of my brain, the way my brain works, and it's just something I wanted to. It's a bit of the presentation was a bit of a love letter to LabVIEW, and the fact that these guys are desperate to have that type of tool. And so every time you use a variant as an input, you're essentially buggering up that tool, for example, because you can't run that front panel and give it an input. So one thing I'm going to propose is that actually if you're into this, then any non-runnable VI, any VI you cannot run just by running, looking at shouldn't be a wrapper. You should always have another sub-VI that runs on, I think it's functional programming is the latest thing, but is a runnable data-ready VI underneath that you can just pop up and go, that's data, look, doing data stuff. So there's a few things that cropped up out of it that are kind of interesting. But anyway.
Suspend going cold.
That's
got to be the best feature in LabVIEW.
And I never use it.
Nobody uses it.
No, I never do. Every time I watch it, I was like, this is brilliant.
So when you get to a sub-VI, stop.
I just put a breakpoint in something.
Then you can actually go and interact with the sub-VI, change the inputs, and affect what goes out of your sub-VI, and then return back to the thing that was used.
Oh, it's almost like I said, it's better than a pause.
So it stops on the sub-VI, and you can interact with it, play with the front panel controls, and then when you resume, it takes whatever you set on the front panel and passes it.
It goes back to the beginning of the sub-VI.
But if you've got a sub-VI that adds one number that was taken as an input and then adds on whatever is set on the control value, and normally you pass in a constant to that, you can interact with the control on the front panel. And if you normally pass in a constant value 5, you can interact with it, say knock it down to 3, and it will do the operation of whatever you set on its front panel, rather than what was passed in as the input.
So you get a chance to change it before it runs, basically.
Yeah.
You didn't have to keep stuff in.
Yeah, I mean the other aspects I talk about is hierarchy depth and things like that. It's discoverability. It's you want to be able to, if I see something happening on my block diagram, I want to go and find out where the action is in the as quick as possible. I don't want to go through 15 layers of abstraction to the point where something quite unrelated happens to the thing that I was looking at. And that's been a problem. For some of my code, I've done sort of abstraction layers, and then I've completely shrunk them back again and said, well, you know, the benefit of an abstraction layer is less than the pain it's causing me.
Especially real time stuff, you just can't.
Yeah, I just want to, you know, I just want to be able to solve the problem as quick as I can. So going through 5 layers to actually see the bit that is logically doing the job is too much for me. It's like having a big mansion and you walk into the kitchen and you wonder why you got there. You know, because you had to go through 15 rooms to get there. And that, so my brain doesn't work like that, and I'm sure I'm not the only one. But I need that response time. I mean, my typical sort of situations, if I'm given a bug, I can usually sort of solve it in my own code in sort of 15 minutes or less. It's very quick. But that's because my debugging mode is no different than my programming mode.
But I think I must work the same, but if you're doing it every day, it doesn't work.
Well, no, and it breaks up. But that's acceptable, that's life. But that always used to be the way with C code, isn't it?
Yeah.
You know, when in Pascal, so you have to program a different way.
I know.
And that's, you know, there's a lot of advantages to the FPGA stuff, but that's one a big drawback.
Yeah.
You know,
You
to
change
me,
your style.
yeah, lots of changes and then monitor them. But I mean, the big selling point for me for landing was that it really fitted my brain in that way. I didn't have to with this. But anyway, back to my problem. If anyone's ever done 2D picture stuff and can offer me help and advice, I'm rather like it's the bits I've got left are.
It's a good challenge.
It is, well, that's the reason. I wouldn't have done it otherwise. It's going to be, in the presentation, it's going to be used for about a second where I say, JavaScript, I get really excited about it. Look, here you go. So there's no value in it at all, really. But it was kind of interesting to do. It's very much outside of my comfort zone.
Not being mean, but isn't that original robot crane example doing sort of that?
Yes. Yes, it does.
What's the difference then? Because before some alterations.
What happens? What the difficulty for me is the recursive stuff. It's not working out a way of thinking it will work. Just the fact that it sticks your last one up first of the picture. Like you say, it's more than likely
It's
the order.
The order in the data. Absolutely.
But you know, I don't. This kind of pictorial stuff. Does any of us do any of it much? I don't know. It's very strange to me. I mean, I've never done it in my career.
I did a little bit where I
Yeah.
couldn't afford a vision toolkit, so I had to do it manually.
Yeah. It was quite interesting. I quite enjoyed it.
I did one for mapping with the robots. It's the same thing. It's all angles and lines, but I can't remember the name now.
No. No. I was hoping somebody said, "Oh yes, I've done something like that." Give me a little code. I've got 2 April, so it's only about 3 evenings' work so far.
I think I've got some code on the community for the president's line algorithms. So you can do the line training if you want.
But who when?
The way it draws the lines into there is a certain algorithm.
Oh,
So
right.
like how it decides when to go up and then across. And so I was playing with it at that level, but I can't remember it. I think it's on the community somewhere.
Rather than rectangles, why don't you just shoot really fat lines?
You don't do it.
You could probably do a line that just put the weight up.
Yeah.
Yeah, have you done?
Oh yeah, that'd be.
There you go.
I'll go to the pedals, yeah.
Have you done them sort of fuzzy?
I think the way I'm trying to do it all the way he does it. So I think he does 16 pink, grayish pink circles. Then see the output from the drawing of the branch needs to be at the point where you start your pedals.
He'll have the advantage in JavaScript to be able to use transparency looks on. Do that nice thing?
Oh, I don't use it.
Do you get transparency? You do.
I'm asking.
Oh, okay.
That's pretty good. I don't think he does use that. I think it's.
Oh, right.
I'll try and find the code for the Wilson. I'll say it's where it is contrived. That's there.
Are you calculating all the branches and then drawing them all together, or doing the calculus? Yeah. So I had kind of a similar issue with the assert thing, so I'm doing recursion in that. And I think I had to end up doing all the calculations, get an array of calculations, and then just reverse it to get to the first one.
The ironic thing is the reason I'm doing this is to just demonstrate how interactive LabVIEW is.
Yeah.
I mean, they've come up with names. It's reactive programming, and I think they call it, which I quite like. Yeah, which is why when you said reactive code, I it's pricked up. But I quite like the term reactive programming. I use Immediacy, but there's very little out there. This is the only thing I can add. There's no studies.
You're trying to do something very much outside LabVIEW's remit, aren't you? And
Yeah.
find a similar example that looks different with actually.
Okay, this is only 10 hours away from.
He's done a tree growing blossom. LabVIEW would be doing, I've got a graph, I can do this. I can do this with this data set that's coming in.
Yeah. I want it to be the same as that, because I want to say that. Because that's the outcome is what they're trying to program is the interactivity. That's the thing that's struggling with. That interactivity is just incredibly difficult, because essentially for what he showed there, you've got to know the domain that you're doing. That's what I say. You can't use a slider. That's actually a very basic user interface problem. You've got a double, and you never use a slider. That's done. It occurred to me when I was looking at it, I was thinking, man, he's quite contrived, isn't it? But you know, it was a big JavaScript conference not very long ago, and it was kind of nice. And these days, when people are sort of saying, "Have you used clunky or that?" You think, "Wow, it's not so bad." Ask about the presentation. I don't know. You said it. I can't do comedy one all the time. You have to do something different. I like the psychology of programming and LabVIEW, and I think people treat it like another language, and actually it's not. It is quite different. And your mind is different when you do it, I think. I think if you've never done texture-based languages, especially the harder to do sort of ones, going right from the past, you kind of forget that. You just, oh, graphics are clunky, oh, it's quite big and bloated. Actually, it's got some advantages. Right then, that's all. We're done.
Yeah.
Subjects for next time. Anyone? Chuck them up.
You'll be post CLA.
Yeah, so there'll be. We can do a review of the CLA summit if anyone's interested. You can't get there. I might take my camera with me.
I've hopefully got a spot on LabVIEW on the web, which I can
Yes. Actually, we've got what we've got. It's James presenting stuff.
Oh, yeah.
We've got 1, 2, 3, 4. That's,
I guess Rich.
Thomas. Yeah, he's doing everyone laugh at my code. So.
Oh, yeah.
Of course they won't, it'll be beautiful. Yeah. If it's anything like a user interface stuff.
Oh,